Hello and namaste. This is me Dinesh Bishwakarma once again with you. In this video, we are going to learn how to import the DEM, that is digital elevation model, and to make slope, aspect map, and do the hillshade analysis. Okay, before that, we need to know about the DEM. What is a DEM? DEM stands for the digital elevation model. Okay, it is a 3D computer graphics that represents the elevation data to represent the terrain that may be of a planet, moon, or asteroid. We can generalize it as a image in which every pixel is occupied by the elevation value. Okay, there are different satellites that provides us the DEM, digital elevation model, just like AstroDM, ALOS Pulsar, SRTM, DEM. Okay, in this video we are going to use SRTM DEM. Okay, for this let's type or search SRTM DEM. Okay, you can see here SRTM Digital Elevation Data version 4. Let's import it. Okay, now I'm gonna rename it as a DEM, and for it we need a region of interest. Let me add the region of interest, that is done, or you can rename it as ROI. So now we need to clip the DEM. Okay, the DEM is provide of whole this globe. So let's clip. Okay, I'm gonna give a variable data, then DEM dot clip ROI. Okay, now let's display the layer in the map. Okay, data. Before that, I'm gonna center the object. Map dot center object. Which object? That is done. And I think the z value will be 8. That will be perfect. Now let's run. Okay, down. Oh, sorry, that is ROI. Now let's run. Okay, now the map is scanned to our ROI. Now let's inspect. Okay, now let's click on what does the each cells represent. Okay, click on it. The elevation is 338. Okay, in this the elevation is 831, and here it is 587, and here it is 652, and this size 319. So it shows that there is change in elevation value. Okay, we can see here it. Now let's make some visualization. As you know, this is one band. Okay, now let's do stress 2 sigma, and let's make color visualization. For it, let's create a platelet. So sorry, plate. For load value, I'm gonna use the green. Then for the average altitude, I'm gonna use the yellow, and for the more higher altitude, I'm gonna use the red. Now let me apply. Okay, now we can see here the green one is the one which we have given for the lower altitude. Okay, let's see the elevation here. Here is 240 meter. Okay, and now let's see on this red value. It is 1359. Okay, now here it is 1308, and this side 1103, and this is the average one. This is 599. Okay, By this way, the elevation of the different places can be visualized. Okay, now then after we have to calculate the slope. To know about this, what is slope, let's see. What is slope? Slope is the degree of inclinedness. Okay, for this, let's make a slope map. Okay, for seeing the documentation of slope, let's go on docs and type slope. Okay, make the habit of reading this documentation, it will be easier for this. Okay, now for to calculate the slope in degrees from 10 dm, you need this command or this code. The argument is an elevation image in meters. Okay, now let's do. Okay, in this place, I'm gonna add slope variable and e dot terrain dot slope. Okay, now the image or DEM is or the input is the data as I have clicked it. Okay, now let's add name dot add layer. Okay, I'm gonna add this row. I'm gonna remove it. It is not now in use. Okay, now click on run. We can see the slope here. Okay, this is a bit dark in color. Let's make some visualization. Okay, now here we can see this is single band and it ranges from the 0 to 90 degree. Now let's customize the visualization. Let me make this stage 2 sigma and platelets. Sorry, plates. Okay, green, yellow, and the red. Okay, and let's click on apply. Let's see the visualization. Okay, and as we have already said that the upper part is steeper and there is more slope. Okay, and on here it is the valley area, so the slope is less. Okay, yellow shows that the slope is mild or steepness is mild. Okay, by this way you can see here. And now this is the slope. Let's make the aspect map. For this, same as the slope, let's replace this slope by aspect. Okay, let's rename the variable name also aspect, and here also. Okay, now let's run. Okay, let's say about the what is the aspect. At first, aspect is the orientation of slope that is measured clockwise in degree from 0 to 360, where 0 is north facing and 90 is east facing, whereas 180 is south facing and 270 is west facing. Okay, so now let's see the output we're seeing here. Okay, this is a bit odd in visualization. Let's change for our easierness. As you know, the value ranges from 0 to 360, and let's divide it into the sum plate. Okay, blue, green, yellow, and red. Let's say and apply. Let's see what happens. Okay, you can see here the blue means the orientation of slope is 0 to 90 degree from the north, and same wise green means 90 to 180 degree, and similarly there Yellow means 180 to 270, whereas the red means 270 to 360. This means that this red one is facing toward the north side, or 270 degree to 360 degree. Okay, this by this way we can know the aspect. Now the another product that we can do from the DEM is hillshade. Okay, now let me remove all this. Okay, what is a hillshade? For let's find out what is hillshade. Okay, hillshade is a grayscale 3D representation of the surface with the sun's relative position taken into account for the shading of the image. And this uses the altitude and azimuth properties to specify the sun position. Here the azimuth means the direction of sun from the north, whereas the altitude means the direction of or the angle of the earth from the horizon towards the vertical. Okay, for this let's do the task and see the result here. Okay, now source here. Hillshade. Okay, now you can see here e.train.hillshade is our code. So we're gonna compute a simple hillshade from the DEM. Okay, now let's see the arguments. First one is input, that is the image, elevation image. And next one is azimuth, that is a floating value and its default is 270 degree. Okay, and elevation is floating value and its default is 45 degree and it returns our image. Okay, now um, let's assign a variable hillshade. Okay, now e dot train dot hillshade. Okay, input is the data, and let's give the azimuth of it will be better if I give 135, and the elevation will be better if I'll give it 45. Okay, now let's add it on the map dot add layer, and let's add hillshade. Okay, now let's run. Let's see the result. Okay, now it's loading. Yeah, we can see the hillshade. We can see here when the sun position is in 135 degree from the north and 45 degree from the horizon, then we can see here the shadow forming here. Okay, this is a shadow that is formed by the sun. So this is the hillshade analysis. So in this video we have done the slope, aspect and hillshade analysis by using the SRTM digital elevation data. Okay, by this way we can make the different analysis on them. Okay, this much for this video. In the next video we are going to learn how to export the images from Google Earth Engine to the Google Drive. Okay, see you on the next video.